Alright guys, number 16. We have the integral from 1 to, this is e at the top, of ln of x over x dx. And I said, whenever you see this, first of all, it's a quotient. So I'm looking at the problem, I can't integrate it. And it's a quotient, which means I definitely have to use u substitution. Or I have to separate it out into two fractions like we've seen earlier. And I can't do that. So whenever you see ln of x, that's always going to be your u. You will never learn a way to integrate ln of x by yourself. So if u is ln of x, du will be 1 over x dx. So then dx will equal x du. Alright, let's go back and plug everything in. This becomes the integral of u over x times du x du. I apologize. And I'm also going to change my bounds now because I've changed things into u. So I'm going to plug 1 into the ln of x, and the ln of 1 is 0. E into the ln of x, and the ln of e is 1. And I will see that now that I've done my u substitution, my x's cancel out. Alright, so this whole thing becomes the integral from 0 to 1 of u du. Alright, that equals u squared over 2 from 0 to 1. Plug in 1, that's 1/2. Minus plug in 0, that's 0. So 1/2 minus 0 is 1/2. Alright, number 18. I'm skipping 17. It had a star next to it. Anything with like an asterisk or a star next to it is a BC calculus problem. This is the integral from 0 to pi over 6 cosine theta over 1 plus 2 sine theta d theta. I'm looking at my quotient. I can't separate it into two things. I can't simplify it with algebra. So I'm always going to test first that the denominator is my u. 1 plus 2 sine theta. du would now be 2 times the derivative of the sine, which is the cosine of theta, d theta. This makes d theta, if I solve for it, du over 2 cosine of theta. Alright, let's go back and rewrite my expression. It's the integral of cosine of theta over u times du over 2 cosine of theta. My cosine of thetas cancel out. But I pick up this extra 1 over 2 term, so this is going to become the integral of 1/2 1 over u du. Alright, in the meantime, also, I need to change my bounds. My original bottom bound was 0. If I plug 0 into here, I've got 1 plus 2 times the sine of 0. The sine of 0 is 0, so 1 plus 0 is 1. Now I'm going to plug pi over 6 into my u. The sine of pi over 6 is 1/2. So I've got 1 plus 2 times 1/2. And 2 times 1/2 is 1, and 1 plus 1 is 2. That becomes my top bound. Alright, now I'm going to integrate. So I've got 1/2. The integral of 1 over u du is ln of the absolute value of u from 1 to 2. Plug in ln of 2. So we've got 1/2 times ln of 2 minus ln of 1. ln of 2 minus ln of 1 is the same thing as ln of 2 divided by 1. And I'm going to look to see if that's my answer. If my answer is here, 1/2 ln of 2 over 1, or ln of 1/2 ln of 2, and it's not. This looks really similar, but that's not the same problem. It's got a negative. This looks really similar, but it's missing the half. Okay, so it can't be that one, it can't be this one. Definitely nothing to do with 3/8 or 3/2. So I really think the answer is E. Let's just check. Since I can take this and bring it up as a power, that would make it the natural log of 2 to the 1/2, which is the square root of 2. So that's the answer. Alright, number 19 here. Let's see what I have. I believe that this is from 2 to the square root of 2 to 2. That's what I'm going to go with. It's a little bit hard to read. Alright, so I'm looking at my quotient. Now, if this was u squared minus 1 over u, if it was the opposite, if it was reciprocal, I could actually split them up. If you have one term in the denominator, you can split the numerator up, but you cannot do the opposite if you have one term in the numerator. So I need to go to u substitution again. I'm always going to try the denominator first. And in fact, I'm going to use another letter because the u will get really confusing. W is going to be the denominator, u squared minus 1. So dw would be 2u du, which makes du equal to dw over 2u. All right, well, let's give this a shot. So now this becomes the integral of, we've got a u up top. This is w. And dw over 2u. I'm going to cancel those u's. I'm also going to change my bounds. I'm going to plug root 2 in here. And root 2 squared will be 2. 2 minus 1 is 1. So that becomes my bottom bound. I'm going to plug 2 into the squared. So 2 squared is 4. And 4 minus 1 is 3. Alright, so now I'm looking at the integral from 1 to 3 of 1 over w dw. This, we should know by now, is... Oh, I made a mistake. Look, I forgot about my 2. I'm sorry, my 2 has to come through the integral sign, so that's actually 1/2 that integral. Alright, the integral of 1 over w is the natural log, so 1/2 the natural log of the absolute value of w from 1 to 3. Let's plug this in. Natural log of 3 minus natural log of 1. 1/2 this whole thing. Let's look at the same kind of problem from before. Natural log of 3 minus natural log of 1 is natural log of 3 over 1, which is just 3. And bring the 1/2 power up. So that becomes the natural log of the square root of 3. That is option A. Number 20. Alright, this one looks really similar. The big difference between this is that bottom power is being raised to the bottom term is being raised to the second power. It doesn't stop me from doing the exact same substitution that I just did. So let me go ahead. I have the integral of the square root of 2 to 2 u du. I'm going to go ahead and make that same exact substitution. So I'll go through the same motions. W is u squared minus 1. dw is 2u du. du is therefore dw over 2u. Alright, let's plug this in so it becomes the integral of u over w squared now. dw over 2u. And we're going to cancel out those u's that we had. I'm going to bring that 2 through now so I don't forget about it. That's 1/2 the integral of 1 over w squared dw. Let me replace those bounds right away. Same bounds are going to happen as before because it's the same exact u. So my root 2 squared is 2 minus 1 is 1. My 2 squared is 4 minus 1 is 3. Alright, so now I'm just integrating something that looks very similar but has subtle differences. This is w to the negative 2 dw. Integrating w to the negative 2 makes it add 1 to the power, negative 1, divide by your new power, so divide by negative 1, from 1 to 3. Alright, I think this is a little bit easier to look at if we look at it like 1/2 times, negative 1/2 times 1 over w from 1 to 3, which is the same exact thing. Now it's negative 1/2 times, plug in the 3, 1/3 minus plug in the 1, 1. So negative 1/2 of, running out of space, but, and colors, negative 1/2, 1/3 minus 1 is negative 2/3. So this becomes 2 over 6, or 1 over 3. All right, and that would be option E.